Okay, girls. This is grade 8, chapter. This is supposed to be chapter 12 in your book, okay? Mine says 10, but yours should say 12. Okay, so the lesson is Introduction to Set Theory. That's what we're doing. Okay? All right. In this lesson, you must know all these 6 things. All these 6 things you must know. Not one, not two, not some, not maybe, all of them. I don't want to hear, I don't know, because you have to listen carefully to what we are explaining in the video. Make sure you write notes. Make sure you do your work correctly. There is no, I don't know. Okay? All right. So you must know how to define a set. So after this video, you'll be able to define a set. You will also be able to know how to write a set in 3 different ways. Not one way, not two. You must know all the 3 ways. All the 3 ways. You must know how to define an empty set. You must know how to find the cardinality of a set. You must know how to classify sets as finite or infinite. Okay? And then you have to decide whether 2 sets are equal or equivalent. You will understand these 2 words are not the same. These 2 words are not the same. They're 2 different words. One is equal and the other one is equivalent. Okay? Equivalent. So, at the end of this video, these 6 things you must know how to do correctly. The one that you don't understand is the one you practice more so that you get to understand. Okay? All right, so we start. What is a set? A set is a collection of objects. Like students in 8A, that is a set. Students in 8B, that is a set. Students that Miss Lillian teaches are all the students Miss Lillian teaches. That's one set. Whether they're in grade 6, 7, or 8. If they take all the students that Miss Lillian teaches, that is one set, okay? Students in Murejib school is a set. All the students who go to Murejib school. Okay? All Emiratis, that is a set. All quadrilaterals, that's a set. All Muslims, all non-Muslims, all these are different ways of you can write a set. Okay? All letters in the alphabet, all Emirati women. These are different sets. So it's a group of objects. Okay? Now, a well-defined set. You should know what is a well-defined set. It is a set that we can easily determine if an object belongs in that set or an object does not belong in that set. So if you can easily tell that this object does not belong in this group, then this is a well-defined set. Okay? Now, we give examples. Anyone can identify who is in 8A and who is not in 8A. So if I walk into 8A and I see who? Adari, because she's always never in 8B. When I walk in 8A and I find Adari in 8A, so I know it is a defined set because I can identify quickly who does not belong in 8A. Anyone can easily identify who is a Muslim and who is not a Muslim by their dressing. A lot of Muslim men wear the kandora, and a lot of Muslim women wear the abaya and the shayla. So it is easier to identify a Muslim individual from a non-Muslim. Okay? You can easily identify what is a quadrilateral and what is not a quadrilateral. If you don't have 4 sides, then you are not a quadrilateral. So it is easier for you to identify what is a quadrilateral and what is not a quadrilateral. So this makes it a well-defined set. Okay? Now, let us think about what is an element. If you belong to the set, then you're an element of that set, or you're a member of that set. Okay? 8A has 30 elements. Why? Because there are 30 girls in 8A. And I know all the 30 girls. Okay? So, Mariam Khamis is an element of set grade 8B because she is in 8B. Muzna is not an element of set 8B because she is not in 8B. That's how I know who is in a set and who is not in a set. A triangle is not an element in the set of quadrilaterals because it does not have 4 sides. Okay? A kite is an element of a set of quadrilaterals because it has 4 sides. So you should know who is a member and who is not a member. Okay? Alright. Now, let us determine whether this is a set or whether the statement is true or false. Fujairah belongs to set A, where A is a set of Emirates in the UAE. So this is a true statement. This is a true statement because Fujairah is in the UAE. And it is also an emirate in the UAE. Like if I wrote Alain over here, and I said this, Alain will be false because Alain is not an emirate. Okay? So, who are the Emirates? Abu Dhabi, Dubai, Sharjah, Ajman, Ras Al Khaimah, Al Quwain, and Fujairah. So, because Fujairah belongs to this list, then it is a true statement. The set of 27, we're asking if 27 belongs to this set. So let us see if this is true. We know that this set continues indefinitely because it has the ellipses. These 3 dots are called the ellipses. Okay? Now, so I need to continue to check if 27 belongs there. What do I notice? For me to get 5, I added 4. So let me see. 5 plus 4 is 9? Yes. Is 9 plus 4 13? Yes. Is 13 plus 4 17? Yes. So I should continue by adding 4. So if I added 4 to 17, I get 21. If I add 4 to 21, I get 25. If I add 4 to 25, I get 29. Like that. And this continues. So I already checked. 27 is missing. So this is false because after 25 is 29. So 27 is missing. And each element is found by adding 4 to the previous element. So this is false because 27 is missing. Okay. Now this says Z is not a member of this set, which is false. Z is here. Okay. I can see Z. So it is false. This is a false statement because it says Z is not in the set, yet Z is in the set. Okay? So now you need to know how to find an element in the set and an element that is not in the set. You have to read and think about what you read. Very important. Okay? All right, now we're here. How to write a set in 3 different ways. So there are 3 ways to designate a set. You either use a list or roster method, or you use a descriptive method, or you use a set builder notation. What are the 3 ways of writing a set? A list or roster method, descriptive method, set builder notation. List method, you use your braces. Make sure you use the braces, okay? These are not called brackets, they're called braces. Okay, I think I forgot to do an example. I did another example, but I'll show you later, okay? All right, so use the braces. And descriptive, you answer using complete sentence. You write a sentence, okay? So you write a sentence May and March are the only months that start with the letter M. There you go. All right. And then here you have a set builder notation. A set builder notation is written like this. You should have brackets. You should use variables. Sorry, you should use braces. These are called braces, not brackets. Braces. So you use the braces, and then you should use variables. There should be a variable, a set, and a definition, like that. Okay? It can be written in 2 parts or 3 parts. So how do I read this? A set of element X, where X is a natural number and X must be less than 7. Okay? So I want the elements of natural numbers that are less than 7. And which natural numbers are less than 7? These ones. So here is the set builder notation. Here is the answer. Okay. All right. So here is the roster method. Here is the roster method. How to write a set. You use braces. See, I wrote it over there. You must use commas between the elements. The commas are the ones that separate the element from another. So, if I write 249, this is one element because there is no commas. If I write 2, 4 commas, and I put the commas between 2, 4, and 9, these are 3 elements. So this is 1 element. This is 3 elements. Okay? Order is not important. So I can write 942, 429. It's the same thing. You must use capital letters to name the set. You cannot say set A. This will be wrong. You must say set A, capital letter. Okay? Now let's do an example. Write the set of months of the years that begin with the letter M in English. This is the question. They want the set of months that be in the years that begin with the letter M. So I wrote all my months in a year. January, February, March, April, May, June, July, August, September, October, November, December. Okay? Then I circled the ones that start with M, which is March and May. So my set M is March and May or May and March. It doesn't matter. Order is not important. I separated with my commas. So because we have 2 elements. Okay. Now you want to know whether this set is well defined. Yes, this is a well-defined set because I can clearly identify easily which months start with M and which ones do not start with M. The question also said I can only use English. It didn't say I can use any other language. So my months are in English and I can easily see which ones start with M. So I wrote here, what is my justification? May and March are English words that represent months in a year and they start with the letter M. So that's how I answered that. Okay. Oh. Okay. All right, so now we do number 3. We do number 3, how to identify a null set. Another name for null set is empty set. A set with no elements is called a null set. Okay? A set with no elements is called a null or an empty set. So the symbol is either the 0 that is crossed out or the braces that are empty. You must put empty braces like that for you to show empty set. There is nothing there. Okay? So let's look at different scenarios to see which sets are empty. The set of woolly mammoth fossils in a museum. This is not empty. Why? If I Google, I will find a museum that has a woolly mammoth fossil. Okay, because woolly mammoth fossils existed at some point and some museum is holding them. Okay, so the set is not empty because there are museums that have woolly mammoth fossils. And I said how I know, because if I Google, I will find a museum that has one. Okay, now here, you see this? What did I use? This is written as a what? Set builder notation. See? Set builder notation. Okay? And this one, a descriptive method. You see? This is descriptive method because you only used words. Here you have set builder notation because you have variables. Alright. So they want an element X where X is a living woolly mammoth. This is false. So this is a null set. There is no woolly mammoth that exists right now. All of them are dead. They are extinct. Yes? So I don't care where I go, I will never find a woolly mammoth living. So this is a null set. The set is definitely empty because woolly mammoths do not exist anymore. There is no living woolly mammoth in the world today. Okay? So this is another way of me writing a set builder notation. I want an element in this set and the set of natural numbers between 1 and 2. So this is an empty set because between 1 and 2, the numbers are decimals or fractions. And natural numbers are only whole numbers. So therefore, there is no natural number between 1 and 2. There are no natural numbers between 1 and 2. Remember, from term 1, you should remember natural numbers are whole numbers greater than 0. Or they are called counting numbers. So we've done 3. Now we need to do 4. Find the cardinality of a set. Finding how many elements are in a set. Okay? So your answer must be a natural number. It must be a natural number. Or 0. Okay? Your answer definitely must be a number. So 0 or actually any whole number. As long as it is whole, then you can use it as the cardinality of a set, to define the cardinality of a set. So you're counting. When you want to find cardinality, means you're counting. So finding how many elements are in a set, or it is the number of all elements in a set. The symbol is N and the letter that represents the set. So N, capital A, put it in brackets, not braces. Here you will use brackets. All right. So in this set, you've been given the set M and they told you to find the cardinal number. So the cardinal number of M is 6 because there's 6 numbers in this set. 1, 2, 3, 4, 5, 6. Okay? All right. Here you want the element X. X has to be a natural number. How do I know? Because this N means natural. Okay? X has to also be less than 16. So I want all natural numbers less than 16. I wrote them all here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. When I counted them, I found 15 elements. So my cardinality for D is 15. So this is my answer. And this is my answer. Okay? Alright. So here, how many elements do I have? I have one element, which is 19.5. So the cardinality for C is 1 because there's only one number in the set. All right, here, 0. My cardinality is 0 because it is a null set or because the set is empty. Okay, so we have finished that. Now we are on part 5. Classifying sets as finite or infinite. For you to be finite, infinite is how you pronounce this. Finite or infinite. All right. So for you to be a finite set, you either have no, there is nothing in your set, or your cardinality is a whole number. That means you can finish counting. That means it stops. Okay? For you to be an infinite set, first of all, you cannot be empty. An infinite set can never be empty. It has to have something inside there. So your cardinality is not a natural number because you cannot finish counting. Okay? The infinite set is the opposite of finite. So if you are infinite, it means you're not finite. Also, for you to know a set is infinite, you will see the 3 dots, the ellipses. If you see the 3 dots, this is definitely this is definitely infinite. It is definitely not infinite. So when you see the 3 dots, you are not finite, you are infinite. That's what I mean. For you to determine whether you are finite or not finite, that means you should see the 3 dots. If you see the 3 dots, you are not finite. You are infinite. Not finite and infinite means the same thing. Not finite. But learn to say infinite. This is the correct way for you to say. So you say infinite. Don't say, well, up to you. All right. So here are examples. Classify each set as finite or infinite. Okay. So what kind of notation is this? Set builder notation. You should know when you look at it, what kind of notation is it? Is it list? Is it descriptive? Is it set builder? You need to know. All right. I need an element x, where x is a natural number, and x has to be less than 100. So it's all the numbers from 1. It is all the whole numbers from 1 to 99. See, I want all natural numbers less than 100. That's what this means. Okay? So it has 99 elements because if you count 1, 2, and up to 99, you'll find 99 numbers. So the cardinality of this set is 99. So this is a finite set because we have 99 numbers. I can count all of them and finish counting. Okay? So that is why it is a finite set. Finite. All right. Set R is the set of letters used to make Roman numbers. Roman numbers can only be made by these 6 letters. C, I, V, X, L, M. You cannot use any other letters to write a Roman number. Okay? And there is no ellipses. As you can notice, there's no 3 dots. And they said end. That means it stops at M. Okay? So, Roman numbers can only, this is also tells me this is finite. So, because I can only use C, I, V, X, L, and M, this means the set of R for Roman numerals is finite. There. And I also wrote my cardinality is 6, and 6 is a natural number. Okay? Is there another example? I must have had another example. Let's see. Maybe there is. Yes, here. So I already know it is infinite because I saw the ellipses right there. And I cannot finish counting. This one tells me it will go on forever and ever. So the set is infinite because it has ellipses and it is an unlimited number of elements in the set. There is an unlimited number of elements in the set. The 3 dots shows it will continue without stopping. Okay? So this is infinite. Underline. So that when you study, it is easier. Alright, set M is the set of students in grade 8. So this is finite because I can finish counting all the girls in grade 8. And I will get a natural number. Okay? This is a finite set because when I count all the girls in grade 8, I will find a specific natural number. The set of hours in a day, this is a finite set because there are only 24 hours in one day. And 24 is a natural number. 24 is a natural number. Okay? The amount of sand particles in the desert, this is an infinite set because you cannot finish counting all the sand particles in the desert. Okay? The amount of colors in the UAE flag, this is finite because the UAE flag has only 4 colors. We cannot use any other colors but those 4. The red, black, white, and green. You cannot use any other colors. You must use those colors. You can use the colors differently, but you must use the 4 colors. Okay? All right, number 6. Now we are here. Equal and equivalent sets. Like I said in the beginning, there is a difference between not different. There is a difference between equal and equivalent. Okay? When we use equal, you have to use the equal sign. When you're saying equivalent, you use the congruency sign. Okay? They must look the same for you to be equal. And you must have the same number for you to be equivalent. So you can be both equal and equivalent. You can be equivalent only. And you can be neither. Okay? If you are equal, then you are equivalent. If you are equivalent, then you might not be equal. Okay? So if you're equal, you're definitely equivalent. So you're both. If you're equal, you're both. If you're equivalent, you're only equivalent. You cannot be equivalent and equal. And then you can also not belong to these two. All right, let's look. I tried to make it a little bit easier. Okay, you have set A. Set A has A, B, C. Set B has B, C, A. Set D has A, C, A, B. Okay? So these sets are equal because they all have A, B, C. They are equal. They have the same elements, A, B, and C. Okay? They are also equivalent because they have the same number of elements. Each one of them, their cardinality is 3. N of A is 3. N of B is 3. N of D is 3. So I can also say set A is equivalent to set B, which is also equivalent to set D. I can say that. should not look the same, but should have the same number of elements. So here you use the cardinality. Okay? Now, if you look over here, set B is A, B, C, A. It's because A has been repeated, you can rewrite set B again. You don't have to repeat. If a letter has been repeated, rewrite it again without repeating the letters. So this set has A, B, and C. So that is why I am saying set A and B are equivalent, even though they don't look the same. That is one way. Another way, I have here 1, 2, and 3, 5, 6, and 7. You see, they don't look the same, but the cardinality is the same. And because the cardinality is the same, set A is not equal to B, but set A is equivalent to B. Okay? Here, these ones are equal and equivalent. You see? Equal and equivalent. Here, these ones are just equivalent. Let's do some examples so that you can see. Okay? So determine if the following pair of sets are equal, equivalent, or neither. Right. PQRS, LABCD. They don't look the same. So if they don't look the same, they are not equal. So then 1, 2, 3, 4. 1, 2, 3, 4. They are equivalent. Set M is equivalent to set L because they both have 4 elements, even if they are not the same. So the cardinality for M is 4. The cardinality for L is 4. M is equivalent to L. All right, let's do this one. Set A, you have that. Set B, you have this. The elements are the same. 8, 10, 12, 12, 8. Both of them have 8. Both of them have 10. Both of them have 12. So set A is equivalent and equal. It is equivalent and equal to set B because they both have the same number of elements. The cardinality for A is 3. The cardinality for B is 3. A is equivalent to B. They both have 12, 8, and 10. A is equal to B. So question 2 has 2 answers. All right. So set D is 2, 1, 3, 213. Set E is 2, 1, and 3. Here there is no comma. Here there is comma. Here there is 1 element. Here there is 3 elements. So it is neither. So they are neither equal nor equivalent. Okay? They don't have the same number of elements and they don't have the same elements. Okay? They don't have the same elements. Okay, that is one reason. They don't have the same number of elements. Okay. All right, 2 more. So here you have 1, 2, 10, and 20. Here you have 2, 1, 20, and 11. So here we don't have 11. Here we don't have 10. So they are not equal, but they are equivalent. Why? Because the cardinality here is 4. And here the cardinality is 4. So the elements are not the same. So it is not equal. And here they are equivalent because they have the same number of elements. All right. So last example. Set A, even natural numbers less than 10. Okay. Now, even numbers that are natural and less than 10. So I listed all my natural numbers less than 10. 1, 2, 3, 4, 5, 6, 7, 8. I circled the even numbers, 2, 4, 6, and 8. So here is my answer for A. So this is A. And then this is set B. The question gave this to us. And if you can see, you have the same numbers and you have the same amount of numbers. Okay? So they are equal because they both have 2, 4, 6, and 8. They are also equivalent because they both have 4 elements in each set. So A is equal to B and A is equivalent to B. And that's it. I don't think I forgot anything else. Okay. Maybe I just say something here, writing a set using builder notation. Yes, maybe I need to repeat this one. Writing a set using set builder notation. Set R contains the elements 2, 4, and 6. So this has been described to you in words. You choose a variable. Your variable will be any letter. Mine is M. So I know the 2, 4, and 6 are even numbers. So I will use the letter E. E in math, capital E in math means even numbers. So this is my set builder notation. Do you see how I wrote it? I wrote my brace. I wrote my variable. First of all, I wrote the set. R equals my brace, my variable like that. And M is less than 7. Okay? Because these are numbers that are less than 7. So how do I read it? The set of M such that M is an even number and M is less than 7. So here is my set builder notation and here is it in words. I described it in words. Now let us do this. Set W contains the elements red, yellow, and blue. So I'm writing W. Okay, I'm going to use N to represent primary colors. Red, yellow, and blue are primary colors because you learned this in art. So the set of N such that N is a primary color. That's how you read this. The set of N such that N, this N is this one, is a primary color. When you're writing this in words, you must use these words here. You have to start with the set of like that. Okay? So designate the set S with elements 32, 33, 34, 35, and then you see the 3 dots. Okay? So let me show you how to write this using a roster method. So roster method, you use your braces, you write it exactly the way you put it, but you put it in braces. Okay? So I have done the roster method. Then the descriptive method, you write it in words. It is the set S. The set S is the set of natural numbers greater than 31 because all these numbers are greater than 31 and they are natural because they are whole numbers. Okay? Set builder notation. I chose my variable to be X. I put this line here, X, and then the set notation. This means set. Okay? You belong to this set. Okay? This N here means natural. And then X has to be less than 31. So I wrote for you these letters here. Capital N means natural numbers if you see it. Capital E means even numbers. Capital O means odd numbers. When you see the R that is written with 2 vertical lines, it means rational numbers. It is written with 2 vertical lines. Normally R is written like this, but they put another line over here. So when they put the 2 vertical lines, they're talking about rational numbers. Okay? Write your notes. Write down your questions that you have. And then do Aleph. I see you tomorrow.